Welcome to This Explainer. Today, we're doing something pretty amazing. We are literally hacking the 3D world around us to decode the hidden architectural building blocks of our everyday lives. You see, our universe isn't just some flat two-dimensional drawing, it's built on this incredibly rich mathematical foundation of 3D geometry. And I promise you, by the end of our time together, you're going to look at everything from a simple soup can to a massive pyramid in a totally different way. Let's dive in.
I want you to tap into your imagination for just a second. Picture our old, familiar friends. The circle, the triangle, the square. You know them well. Now imagine mentally grabbing that square right off the page and just pulling it outwards towards you, stretching it right into the room. Well, congratulations. You've just stepped into the third dimension.
And that right there brings us to a fundamental golden rule you've got to keep in mind. 3D shapes are fat, not flat. When we stretch out our 2D shapes, we totally transform them. They go from being these flat drawings that just have width and height into objects that actually possess depth. So a circle blossoms into a sphere, a square extends into a cube, a rectangle stretches out into a prism. They suddenly take up physical space in our world.
What's really wild is how these abstract geometric names tie directly to the real world. Seriously, just look around you. A sphere? Well, that's the Earth we live on, perfectly balanced in space. Or, the basketball you shoot hoops with. A cylinder is that soup can sitting in your pantry, engineered to stack perfectly on a shelf, or the batteries powering your TV remote. A cone? That's your birthday party hat, or better yet, a delicious ice cream cone. And a cube is a pair of dice, or just a simple tissue box. These shapes are the invisible skeleton of our reality. They are literally everywhere.
Okay, to truly understand these objects, we need to break down their anatomy. Let's start with faces. Faces are the flat surfaces of a 3D shape. And the absolutely crucial thing to realize here is that a flat face acts like an anchor. It allows a shape to stay perfectly still when you set it down on a table. It gives it stability. But watch out for curved faces. If a shape has a curved face, like our friend the sphere, that curve means it has zero anchor. It's going to roll right away from you the second you let it go.
Moving deeper into our anatomy lesson, we have edges. Whenever you have two of those flat faces meeting, they form a rigid edge. Think of it kind of like the seam on a piece of clothing that holds the fabric together. And here is a totally non-negotiable rule of 3D anatomy to remember. Edges are always straight lines. They are never, ever curved. If it curves, it's simply not an edge in the geometric sense.
Finally, to complete our foundational vocabulary, we've got vertices. You can just think of vertices as the sharp points or the corners of a shape. It's the exact spot where three or more of those straight edges crash into each other to form a single point. And hey, this isn't just some abstract math concept. Modern video game designers and 3D animators actually use vertices, they usually just call them verts in the industry, as the primary way to build and bend entire digital worlds. It's basically the ultimate control point.
So, let's see how this anatomy completely changes how an object behaves. On one hand, we've got the highly structured, super rigid cube. It's built up of 6 flat faces, 12 straight edges, and 8 sharp vertices. Now, contrast that completely with the sphere. The sphere has just one continuous curved face. And because it has no flat faces meeting, it has 0 edges. And with 0 edges, yep, 0 vertices. It is a perfectly smooth anomaly.
Once you know the anatomy, you can decode pretty much anything. Let's run through a few more real quick. A cylinder, it's got 2 flat circular faces on the top and bottom, and one curved face wrapping around the middle. A cone has a flat circle base, one curved face, and exactly one vertex at the very top. What about a square pyramid? It has a square base and 4 triangle sides, which gives it 5 faces, 8 edges, and 5 vertices. And a rectangular prism, like a brick, acts as the ultimate building block with its 6 faces, 12 edges, and 8 vertices. See? You're already speaking the language of geometry.
All right, now let's see how all this anatomy builds into an incredible mathematical secret. For 3D shapes made entirely of flat faces, there's this hidden harmony that binds them all together. It was discovered by the legendary mathematician Leonhard Euler, and it's brilliantly known as Euler's formula. It states that if you take the number of faces, add the number of vertices, and subtract the number of edges, the answer will always magically be 2. No way, right? Well, let's prove it.
We are going to test this out using our trusty cube. Remember its anatomy from earlier? First, we take the cube's 6 faces and we add its 8 vertices. That gives us 14. Next, we take that 14 and we subtract the cube's 12 edges. So 14 minus 12 leaves us with exactly
2. The math works out perfectly. Honestly, it feels almost like a magic trick designed to mess with your head. But let's push the boundaries a bit, shall we? Let's try it on something with a totally different structure, just to see if the magic holds up under pressure. Let's put a square pyramid to the test. Its anatomy is completely different from the cube. So we add the pyramid's 5 faces and its 5 vertices to get 10. Then we subtract the pyramid's 8 edges. 10 minus 8 is… Boom! It's 2 again. This perfectly exposes the mathematical harmony underlying the 3D objects in our universe. You can warp, stretch, or change a flat-faced 3D shape however you want, but Euler's formula remains the unbreakable glue holding the whole shebang together. The universe clearly loves order, and Euler's formula is absolute proof of it. Let's do one final rapid-fire confirmation, just to permanently cement this in our minds. A triangular prism. 5 faces plus 6 vertices is 11. Subtract its 9 edges, and yeah, you get 2. The magic of Euler's formula is mathematically undeniable. It's literally a universal constant for flat-faced shapes. Okay, so far, we've been building shapes up and looking at their outsides. Now, let's break them down and look inside. This brings us to the concept of a cross-section. Think of how an MRI scans a human body in slices, or how a 3D printer builds an object layer by flat layer. A cross-section is the flat 2D shape you reveal when you slice straight through a solid 3D object with a flat plane. Basically, you're exposing its internal geometry.
Everybody understands slicing food, so let's use a cake to visualize this. If you take a knife and slice a round cake horizontally, parallel to the table, the flat shape you reveal is a perfect circle. But take that exact same cake and slice it vertically, straight down from the top, and you reveal a rectangle. It's the exact same object, but a different cut gives you a totally different shape. It is all a matter of perspective.
Geometrically speaking, that cake is essentially just a cylinder, so slicing a cylinder horizontally gives you a circle. But if you change your angle and slice that cylinder straight down the middle from top to bottom, the hidden 2D shape you expose is a rectangle. Your angle of attack entirely controls the geometry you reveal. And what this means is that there are incredible hidden shapes hiding inside completely ordinary 3D objects. A straight vertical cut down a cone, that reveals a hidden triangle. Slice it horizontally and you get a circle. But what if you make a slanted diagonal cut through a square pyramid? You get a trapezoid. It's like this geometric magic trick happening right inside the shapes, just waiting for the right perspective to be revealed. Now let's move to our final concept of deconstruction. We've sliced shapes, now let's unfold them. This is called a net. Imagine taking a hollow 3D shape, kind of like a cardboard delivery box arriving at your front door. If you cut along its edges and completely unfold it until it lies totally flat on the floor, that flattened 2D pattern is the 3D shape's net. It's a blueprint. It's the 2D map that actually creates the 3D structure.
Let's test your mental visualization real quick. Imagine you have a hollow cube right there in your hands. You cut the edges and unfold it completely flat onto the floor. Take a second and really picture it. What 2D shapes are going to be staring up at you? Well, because a cube has 6 flat faces that are all perfectly equal squares, the net of a cube is made of exactly 6 connected squares. If you can visualize that in your mind, you have officially mastered the translation between the second and third dimensions.
Wow, we have covered a lot of ground today. You now know that 3D shapes are fat, not flat. You know all about their faces, edges, and vertices. You've uncovered the unbreakable math of Euler's formula, and you've sliced and unfolded these structures right in your own mind. So I'm going to leave you with this. Look around the room you're sitting in right now. Pick an object. What secret 2D shape is hiding inside if you sliced it open? What kind of blueprint would you make if you unfolded it? The 3D world is yours to hack. Keep exploring.